If you're building LLM applications, there's two big concerns that you regularly hear. The first one is hallucinations, but I'd argue that's much less of a problem now that benchmarks and numbers show that hallucination rates are very, very low, in fact, lower than humans performing the same task. And the other big one, which has come up in the last year or so, is prompt injection, or this whole notion of how do you make LLM-based applications or agents secure to data exfiltration, secure to performing unauthorized actions, and so on. This paper that was published just a couple of weeks ago is a great compendium of mechanisms and techniques and just concepts that capture the current best known ways to think about this problem of prompt injection and, as they say, document design patterns for how to build applications that are resilient to such attacks. I'm going to assume that you already know what prompt injection attacks are, but very briefly, a prompt injection attack happens when some kind of malicious text makes its way into the context window of the LLM. And this can happen many different ways. It could be direct user input, but more surreptitiously, it could come from one of the many sources of data that the application itself reads. For example, if your application is summarizing documents or emails, those documents or emails might contain attacker-supplied text, which can end up being malicious instructions to the LLM. And what happens as a result is that the model is then able to perform some unauthorized or unintended action, like sending secret data to some email, for example. Now, of course, people haven't been standing still. There are some existing defenses. There are LLM level defenses which still are heuristic. They use prompt engineering to add some layers of checks, but they still do not provide guarantees. You then have user level defenses like asking the user for confirmation, but the problem is that, of course, you can't automate a system if it's asking for confirmation, and it leads to confirmation fatigue. And finally, you have system level defenses where you try to integrate some verification or control mechanisms, again, using some sort of heuristic or more LLM prompting. And this still doesn't absolutely guarantee that the system is 100% secure. The stance that the authors of this paper are taking is that general purpose agents are very, very hard to secure. And instead, what we should be thinking about is how to design and build very application or task specific agents. And then once you've nailed that down, you can look at the kinds of attack models that particular application is susceptible to and how to design a system around the LLM that, again, for that particular application, makes it secure against prompt injection attacks. And the big idea that they finally articulate in this paper is that there is a trade-off between utility and security. So a general purpose agent might have no constraints on how it invokes tools or how it interprets data or feedback from tools. And that gives you the broadest range of functionality, but it is also very susceptible to prompt injection. However, if you lock down some of that generality while still accomplishing something specific to an application, in other words, if you reduce the utility of the system, you can get better security guarantees. So thinking about and articulating that trade-off curve between utility and security is one of the main ideas in this paper. Let's look at one of these design patterns. There's 6 of them. I'd really encourage you to read the whole paper. But the simplest one is what they call the action selector pattern. And the main idea here is you use the LLM as basically a natural language driven switch statement that picks one of many actions or one of many tools based on natural language input from the user. But that's all it does. It does not look at the output of these actions. So the LLM is not looking at what these tools read. And because they're not able to even see this untrusted data, it eliminates one entire vector of prompt injection attacks. This idea is demonstrated in this diagram where the user is providing a prompt, the LLM is simply picking from some actions, and those actions might invoke tools, read from the environment, read untrusted data, but note that there's no arrow from the tool back to the LLM. So the LLM then cannot be influenced by untrusted data to then perform an unauthorized or unexpected action. So this is an example of how you would design a system around the LLM that is giving you some security guarantees. It is also an example of the utility security trade-off because you can imagine many applications, like, for example, all the coding agents that we have today that really need the feedback from these tools. For example, the feedback from running tests and then looking at test failures. That is crucial to having a good coding agent. But that pattern is disallowed in this setup. A big chunk and a very useful chunk of the paper is actually a bunch of example application designs which walk through the design patterns they've covered in the first half of this paper and how they might be applied to a given application design. So, for example, if you wanted to make an LLM-based OS assistant that is doing fuzzy search over your documents on your local computer, they walk through what the threat model is, what the attacker can do, and then how you might apply some of these design patterns that they've just explained. And they also explain how the application of these patterns affects the utility of these tools. So this is the utility security trade-off made real. The main takeaways then are to really look at application-specific agents rather than general purpose unconstrained agents, and then use these well-articulated, well-understood design patterns to clearly secure these applications, these systems to prompt injection attacks. A lot of the stuff they've written here was somewhat folk knowledge within the LLM and agents community, but the authors here have done a really great job bringing it all together in one paper and really explaining the whole idea really well. If you're building LLM-based applications or AI agents, you really must read this paper. All right, thanks.